8th graders, this is your Molecules Part 2 video. Molecules Part 1 went over the assignments for the week and kind of laid everything out and explaining instructions and kind of what's expected of you for the next couple of weeks. I wanted to go ahead and let you watch that before you do this video because you know, there's a lot of confusion right now with what to do, when is it due, how do I submit this on LabGrades. So that kind of explains the assignments just like I would in the classroom, and kind of let you know what is going on. So this is part 2 of our physical sciences chapter. We went over states of matter first, and now we're doing molecules. So the main question that I want you to be able to answer is, how are compounds different from the elements from which they are formed? So we kind of talked a little bit in class about this, about the elements on the periodic table. If you were in my second period, we got to have this discussion. You know, if you look at hydrogen on the periodic table, hydrogen is a gas and oxygen is a gas, but H2O, when you put those together, they can form a liquid. So the main point here is that the compounds are different from the individual elements in which they are formed. So I really want you to really think about that. So real quick, I want you to just think, what is matter? So think in your mind, this is like your bell ringer. What is matter? So if you need to pause the video, write a couple things down, some ideas down, go ahead and do that real quick. So matter is anything that has mass, which is weight, and takes up space. So what are the building blocks of matter? So matter is anything that has mass and takes up space. So essentially everything around us has matter in it, but what is matter made of? So go ahead and think about that, write that down real quick. And if you said atoms, you are correct. Like I said, I really hate that we're not able to have our classroom discussions because a lot of science, we're having our discussions and doing all these things, and we're not really able to do that right now. So you'll be learning about different types of matter and atoms and elements and things like that. All atoms are not the same. There are different types of atoms. And then elements make up those atoms. So can you think, I named a couple. So what are some elements that some common ones on the periodic table that you can think of? If not, if you can't, like I said, I'm going to send you with these videos a periodic table for you to get used to. Assignment 2 has you, looking and researching elements, not really researching, but looking at the periodic table and getting familiar with elements on there. So if you need to pause this video, go ahead and write down a couple elements that you can think of. So like I said, there's carbon, oxygen, hydrogen, copper, silver, gold. We've talked briefly about the noble gases, argon, freon, xenon, krypton, radon, how they're very chemically unreactive. So there's all kinds of different elements. Like we said before, the periodic table is divided into 3 categories. Go ahead and write those 3 categories down for me. I'll let you pause it and think about that. So we have metals, nonmetals, and metalloids. So that is how your periodic table is arranged. So we're going to learn about molecules and atoms and elements and the difference between them and how they're alike, okay? So your first task is working through your guided notes. just like we would at class. I really think note-taking is an essential tool and a skill that you should have. You should know how to take notes. I felt very unprepared when I got to college and even my high school classes because nobody ever taught me how to take notes and do these things. So I want to make sure that I can help you with that. So your chapter is called Molecules. It talks about the water that you drink. I have my flavored water. The air you breathe, the rock and dirt under your feet, they're all made up of atoms, but there is no air atom, there is no water atom when you look at the periodic table. These substances around us are made up of combination of these atoms or these elements, okay? So whenever those electrons are shared between atoms, a molecule is formed. So your first video in your chapter is 2 minutes and 48 seconds. It's telling you that a molecule is 2 or more atoms bonded together by chemical bonding. So like I said, they don't just like stick together and just happen to stick. There is a sharing of electrons, and that attraction keeps them together to form a molecule, and there is energy stored there. So I want to make sure that you know that those bonds have potential energy stored in them, and when they break, energy is released. So I want to make sure that you understand that. So the second part of your chapter, got my notes out of order now, talks about like kind of a misconception that molecules are made of 2 or more atoms of different elements. And that is a common misconception. Molecules can be made of atoms of the same element. They will bond together. The noble gases will only bond with another noble gas. So neon will only bond with neon, and argon will only bond with argon. Scientists have tried to make them bond with other noble gases or other elements, and they're just very chemically unreactive and won't. But they will bond with atoms of themselves and to make a molecule. You can have molecules with the same atom bonded together. So the next part of your chapter kind of talks about compounds and water being a molecular compound. It has 2 elements, hydrogen and oxygen. And we talked about chemical formulas. So H2O is the chemical formula for water. So on those papers next week, we're going to practice more with the chemical formulas and writing those out. And then we'll even move on to balancing chemical equations and reactions as well. But I want to make sure you have this foundational knowledge before we move on. Your book also talks about how you can predict how atoms will combine to form a molecule. So it talks about how the positively charged nucleus of an atom, so like I said, the 3 subatomic particles, like we mentioned in the first video, are protons, neutrons, electrons. P in the protons for positive, N for neutral or no charge, so that's the nucleus, so it always is positive, and those negative electrons are in the valence shells orbiting around the nucleus. So the further away from the nucleus that shell is, the more electrons it can hold. So there are more than one, well, depending on the element, but some of them have multiple levels. The innermost shell, the one closest to the nucleus, can only hold 2 electrons. So hydrogen has the atomic number of 1. So if you look at the periodic chart, and then my son threw all this on the floor real quick. So, my bad. My chair is really squeaky. So if you look at hydrogen, it has the number 1 up here. So that is for the 1 electron it has orbiting its shell. So I just told you that it can have up to 2. So if you think it can have 2 and it only has 1, do you think hydrogen would readily react with other elements, that it would be chemically reactive, or do you think it's stable and that it wouldn't want to react with other elements? So take a minute, pause this video, think about that. So the question is, hydrogen has 1 electron. The shell closest to the nucleus can have 2. So hydrogen has 1. So do you think that hydrogen is chemically reactive, or that it's stable and it won't react with other elements? So do you think it would do with that electron? Do you think it's happy with the 1? Do you think it would like to react with another element and kind of fill up that shell, or give one away, or share electrons? So think about that for a second. So if you said that you think hydrogen is reactive because it does only have 1 and it wants 2, then you are correct. Hydrogen is a very reactive element. You know, it can easily donate that electron or receive or share. So because it can do all 3, it is very, very, very chemically reactive. So that's kind of how scientists predict how elements will react, as they look at their valence electrons and they're like, okay, this one needs 2, or it, you know, has extra and wants to give some away, or if it's chemically stable. If its shell is full, has the exact number that shell has, then that means that it's not very reactive. So hydrogen is number 1 over here, and it has 1 electron. If you come over here to the far right, these are the noble gases, okay? You can see helium has a 2, okay? So it has 2 electrons in its shell, in its valence shell. So do you think helium needs 2? It has 2. Do you think it would react with other elements? So take a second, pause the video, tell me what you think about helium. So if you said helium is unreactive, you are correct. Helium, you know, like I said with the noble gases, they're like, I don't need you. I got what I need. Sorry, I'm happy by myself. Kind of think of it that way. They have 2 electrons. That's all they need in that shell to be stable. So they're chemically stable. They don't want to bond with anybody else. They will bond with other helium atoms, but they will not react with other elements. And that's true for all of the noble gases here on the far right. They are helium, neon, argon, krypton, xenon, radon. So those elements, their octets are full, they're stable, so they really do not want to react with anybody else. So we'll get into this a little bit more. So we'll talk more about that. Your chapter does the specifics on the water molecule. It says that water consists of 2 hydrogen and 1 oxygen. So whenever you look at that subscript, I talked the second period about this, but not everybody else, because Friday was a little crazy. Sorry. I'm not used to having to do this. So hopefully these videos will get better as time goes on. So H2O. So I tried to write kind of big there. Well, anyways. This is the hydrogen, this is your subscript of 2, and this is your oxygen. So you don't see a subscript here in chemistry if there's not one there. It's understood to be 1. So I told my students in the past, because they really struggle with this, if you need to write the 1s in the beginning, you know, so you can remember, that's fine. I'm not going to take points off or anything like that if you balance an equation and you put a 1 here. because this subscript goes with the element here. So this 2 actually means that there are 2 hydrogens and there is 1 oxygen. Okay, so this 2 goes with this element and this 1 goes with that one. So that kind of helps students sometimes. So that's up to you. So that's the example your book gives. Oxygen has a total of 8 electrons. So if you look at oxygen here on your periodic table, here's the O, it tells you here it's oxygen, and you see the number 8, okay? That 8 tells you that there are 8 electrons. That's the atomic symbol. So 6, 2 are in the inner shell, okay? Because we said that first shell can hold 2. 6 are in the outer shell. So in the outer shell, it can have 8. Hydrogen has 1. So it is this beautiful bonding between the oxygen and the 2 hydrogens, because oxygen has 6. He needs 2 to create a stable octet to have 8. So oxygen bonds with 2 hydrogens to make 8. Okay, so hydrogen, like I said, has that 1. Okay, oxygen says 8, so don't get confused there. Okay, 2 are in the first shell, and then there can be 8 in the second, but oxygen only has 6. Okay, so I'm gonna draw this for you, and my art skills are not the best. We make these in class, and like I said, I might have you guys make these as well out of paper plates if you can get some. If not, that's okay. So this is oxygen. Okay, this is the nucleus. Here is the first 2 electrons in the first shell. So the first shell only has 2. And I'll tell you, for 8th grade science, we're only sticking to the first 2 shells. So you need to know the first shell has 2 electrons. And then second shell can hold up to 8. Okay? Not everybody has 8, but they want to get to 8. Okay? So first shell has 2 electrons, second shell has 8. Or wants 8, I should say it that way. They want 8, okay? So if oxygen has an atomic number of 8, okay, they have 1, 2, 3, 4, 5, 6, 7, 8. So that is the 8 electrons for oxygen. So they want 2 more, okay? I'll highlight these, okay? He wants 2 more. He's like, man, I only have 6 to be stable and be happy. I need 2 more. So it bonds with the 2 hydrogens, okay, to make that stable octet. So that's why water is a very stable compound. Has 8 electrons in the outer shell. It's this happy partnership between the water and the 2 hydrogens, okay? So this is a covalent bond. They're sharing those electrons, okay? That's how water bonds together. And your book tells you about these covalent bonds, how they are a strong bond, between these molecules. So I really hope that these notes help you with your chapter. We're gonna, like I said, I want you to get this foundational knowledge. We're going to build on this. I'm going to have you looking at the periodic table. We're going to make some models. It might be out of a paper plate. You might just draw one like this. That's fine, as long as you get the concept. So I hope this video helped you with your chapter. The big takeaways that I want you to get are, the difference between atoms, elements, compounds, molecules. Make sure you know what those are, and you can say that back to me. You'll have to do that in your assignments, and I'll watch them and read them. If you have trouble, reach out to me on LiveGrades. I'm here to help you. Chemistry is very difficult for most students because you never really had that prior to this year. So this is very difficult for most students, and I really want you to have this knowledge going on to high school. So if you need any help, please reach out to me. I'll be making more videos. We will probably work on this week and next week, and then move on to your next chapter, which again, it will get into chemical reactions and chemical use. So we will really build upon this. So hopefully this video helped you. Message me if you need any help. I'm here for you. Thanks.